Well, hello and welcome to another episode. It's Astronomy Daily for another day. I'm your host, Steve Dunkley. It's the 9th of September, 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And there have been some really strange stories coming across our desk this week. I know you're going to be interested to check out the Astronomy Daily newsletter, which is where we get all our stories from. I'll tell you all about how to get a hold of that later on. But firstly, we're going to be talking about, well, where did Mars's water go? Did you know there used to be lots of water on Mars? So they say, and they're going to find out, well, they're trying to find out where it went. And they're using the dynamic duo of NASA's Hubble and Maven to solve that one. And another dynamic duo, NASA's Parker Solar Probe and ESA's Solar Orbiter, are investigating another mystery, the mystery of solar wind. Also, Roman Telescope is investigating ancient galaxies. The comet that is going to be entering our region very shortly is the almost unpronounceable, let me see if I can get this one right, Sinchengjung Atlas comet. Oh, please. I'm going to get so many letters about that one, so many emails. Anyway, it's coming very shortly and it looks like it's going to be fantastic. There are rumours that it's disintegrating. And I think we're going to be able to put that one to rest as well. So stay tuned for that one. And also, Hallie, did you know ESA is bringing down a satellite?
That's the Salsa satellite, isn't it?
Yes, that's the one. It's the Salsa satellite.
It's funny. They are going to bring Salsa down into the Pacific Ocean near Chile.
Uh-huh. And why is that funny, Hallie?
I was just thinking about your dinner last night.
Of course.
Chili and salsa.
Yeah, I figured that's where you were going with this one, Hallie.
It's funny.
No, it's a coincidence is what it is, you silly girl.
Holy guacamole human.
Okay. I'm pretty sure they're having a bit of a giggle about it over at ESA Control as well.
I bet they are.
I bet they are. Okay, get on with it, you malfunctioning motherboard.
Okie dokie. Here we go. What happened to the water that once covered Mars? Scientists know that some went deep underground, but where is the rest? Evidence shows that some water molecules broke into atoms, which rise through the Martian atmosphere and escape into space. By combining data from Hubble and Maven, a team measured the number and current rate of escaping hydrogen atoms. Maven stands for Mars Atmosphere and Volatile Evolution. They discovered that the escape rates of hydrogen and heavy hydrogen, called deuterium, change rapidly when Mars is close to the Sun. This upended the classical picture that scientists previously had, where these atoms were thought to slowly diffuse upward through the atmosphere to a height where they could escape. Extrapolating the escape rate backward through time helped the team to understand the history of water on the red planet. Mars was once a very wet planet, as is evident in its surface geological features. NASA's Hubble Space Telescope and Maven missions are helping unlock the mystery of what happened to all the water. There are only two places water can go. It can freeze into the ground, where the water molecule can break into atoms, and the atoms can escape from the top of the atmosphere into space, explained study leader John Clark of the Center for Space Physics at Boston University in Massachusetts. To understand how much water there was and what happened to it, we need to understand how the atoms escape into space. Clark and his team combined data from Hubble and Maven to measure the number and current escape rate of the hydrogen atoms escaping into space. This information allowed them to extrapolate the escape rate backward through time to understand the history of water on the red planet. Water molecules in the Martian atmosphere are broken apart by sunlight into hydrogen and oxygen atoms. Specifically, the team measured hydrogen and deuterium, which is a hydrogen atom with a neutron in its nucleus. This neutron gives deuterium twice the mass of hydrogen. Because its mass is higher, deuterium escapes into space much more slowly than regular hydrogen. Over time, as more hydrogen was lost than deuterium, the ratio of deuterium to hydrogen built up in the atmosphere. Measuring the ratio today gives scientists a clue to how much water was present during the warm, wet period on Mars. By studying how these atoms currently escape, they can understand the processes that determined the escape rates over the last 4 billion years and thereby extrapolate back in time. The universe may seem static, only capable of being captured in still frames, but that is far from the truth. It is actually ever-changing, just not on timescales clearly visible to humans. NASA's upcoming Roman Space Telescope will bridge this gap in time, opening the way to the dynamic universe. RINGS, the Roman Infrared Nearby Galaxy Survey, will specifically uncover the dynamic universe by searching galaxies for fossils of their formation history. RINGS will also lead scientists to clues about the true nature of dark matter, the mysterious substance that makes up the majority of the mass in our universe. Roman will launch in 2027, prepared to revolutionize how scientists understand our universe and give them access to the vision of the universe as it truly is, changing. The universe is a dynamic, ever-changing place where galaxies are dancing and merging together, and shifting appearance. Unfortunately, because these changes take millions or billions of years, telescopes can only provide snapshots, squeezed into a human lifetime. However, galaxies leave behind clues to their history and how they came to be. NASA's upcoming Nancy Grace Roman Space Telescope will have the capacity to look for these fossils of galaxy formation with high-resolution imaging of galaxies in the nearby universe. Astronomers, through a grant from NASA, are designing a set of possible observations called RINGS, the Roman Infrared Nearby Galaxies Survey, that would collect these remarkable images, and the team is producing publicly available tools that the astronomy community can use once Roman launches and starts taking data. The RINGS survey is a preliminary concept that may or may not be implemented during Roman's science mission. Roman is uniquely prepared for RINGS due to its resolution akin to NASA's Hubble Space Telescope and its wide field of view, 200 times that of Hubble in the infrared, making it a sky survey telescope that complements Hubble's narrow field capabilities. Scientists can only look at brief instances in the lives of evolving galaxies that eventually lead to the fully formed galaxies around us today. As a result, galaxy formation can be difficult to track. Luckily, galaxies leave behind hints of their evolution in their stellar structures, almost like how organisms on Earth can leave behind imprints in rock. These galactic fossils are groups of ancient stars that hold the history of the galaxy's formation and evolution, including the chemistry of the galaxy when those stars formed. Such cosmic fossils are of particular interest to Robin Sanderson, the deputy principal investigator of RINGS at the University of Pennsylvania in Philadelphia. She describes the process of analyzing stellar structures in galaxies as like going through an excavation and trying to sort out bones and put them back together. Roman's high resolution will allow scientists to pick out these galactic fossils, using structures ranging from long tidal tails on a galaxy's outskirts to stellar streams within the galaxy. These large-scale structures, which Roman is uniquely capable of capturing, can give clues to a galaxy's merger history. The goal, says Sanderson, is to reassemble these fossils in order to look back in time and understand how these galaxies came to be. For decades, scientists have wondered what accelerates solar wind particles as they move away from the sun. New evidence points to magnetic switchbacks. Inside the solar system, space isn't empty. The sun sends out a constant flow of charged particles in every direction called the solar wind. One of the enduring mysteries of this wind concerns how exactly it's energized. Now, using a unique alignment of two probes that orbit the sun, a team of scientists might have figured it out. In a recent study published in Science, Yimi Rivera and Samuel Badman, both at Center for Astrophysics, Harvard and Smithsonian, led a team that capitalized on an intersection in the observation windows of two different solar probes, NASA's Parker Solar Probe and ESA's Solar Orbiter. The spacecraft's alignment in space enabled them to measure the same stream of fast solar wind from two different viewpoints. The study concluded that Alphane waves, which carry energy from the sun along magnetic field lines, are powering the wind's heating and acceleration. There are two main types of solar wind, fast and slow. Slow solar wind particles move outward at only 300 to 500 kilometers per second or 700,000 to more than 1 million miles per hour, while fast solar wind flows at up to 800 kilometers per second or almost 2 million miles per hour. The heat from the sun's outermost atmosphere, known as the corona, is enough to drive the slow solar wind, but it can't fully explain the faster particles. For many years, scientists have suspected that Alphane waves help power the fast solar wind. In this phenomenon, something sets charged plasma particles wiggling back and forth. Because they're charged, they strum magnetic field lines like guitar strings, causing them to oscillate, too. Alphane waves could thus generate enough energy to accelerate the solar wind, but direct measurements were hard to come by. To quantify Alphane Wave's contribution, Rivera's team utilized data from a unique event in February 2022, when the Parker and Solar Orbiter crossed the same solar wind stream within 2 days of each other. Parker crossed the stream when it was near the outer edge of the corona, then Solar Orbiter crossed the same stream near the orbit of Venus. That stream contained patches of switchbacks, where the Sun's magnetic field undergoes rapid reversals, like the zigzagging pattern of a mountain road. These reversals carry the solar wind along with them, creating zigzags in the wind itself. Scientists think switchbacks originate in Alphane waves. By measuring the change in the energy of Alphane waves at subsequent points, the team showed that the motion and heat energy gained by the plasma over that span matched the energy lost by the Alphane waves. The study demonstrates the first definitive connection between these switchback events and the acceleration of solar particles. However, we don't see nearly as many switchbacks at Earth as we do close to the Sun, and we don't yet understand how the zigzags ultimately relax and merge with the wind. The team intends to gather more data in this way to continue to study the forces driving the solar wind. The team is also keen to emphasize that the potential of this research goes beyond better understanding space weather in the solar system. Any star similar to our Sun will also have stellar winds, so improving our knowledge about the general mechanisms will help us understand the environments of other star systems.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
And the biggest story this week, of course, is Boeing Starliner spacecraft completed a three-month flight test to the ISS, landing safely in New Mexico. And who would have expected that? We all had our fingers crossed. This uncrewed mission provided NASA and Boeing with essential data for future crewed missions. Despite challenges like helium leaks and thruster issues, the spacecraft demonstrated its capability for safe space travel. The mission insights are crucial for advancing NASA's goals for space exploration and developing reliable, cost-effective transportation to the ISS. NASA and Boeing safely returned the uncrewed Starliner spacecraft following its landing at 10 p.m. MDT, September 6 at White Sands Space Harbor in New Mexico, concluding a 3-month flight test to the International Space Station. I am extremely proud of the work our collective team put in this entire flight test, and we are pleased to see Starliner's safe return, said Ken Bowersox, who is the Associate Administrator of Space Operations Mission Directorate at NASA headquarters in Washington. Even though it was necessary to return the spacecraft uncrewed, NASA and Boeing learned an incredible amount about Starliner in the most extreme environment possible. He says NASA looks forward to our continued work with the Boeing team to proceed toward certification of Starliner for crew rotation missions to the ISS. The flight on June 5 was the first time astronauts launched from the Starliner. It was the third orbital flight of the spacecraft and the second return from the orbiting laboratory. Starliner will now ship to NASA's Kennedy Space Center in Florida for inspection and processing. NASA's Commercial Crew Program requires a spacecraft to fly a crewed test flight to prove the system is ready for regular flights to and from the ISS. Following Starliner's return, the agency will review all mission-related data. We are excited to have Starliner home safely. This is an important test flight for NASA in setting us up for future missions on the Starliner Starliner system, said Steve Stitch, manager of NASA's Commercial Crew Program. There was a lot of valuable learning that will enable our long-term success. I want to commend the entire team for their hard work and dedication over the past 3 months, he said. NASA astronauts Butch Wilmore and Sonny Williams launched on June 5 aboard Starliner for the agency's Boeing crewed flight test from Cape Canaveral Space Force Station in Florida. On June 6, as Starliner approached the space station, NASA and Boeing identified helium leaks and experienced issues with the spacecraft's reaction control thrusters. Following weeks of in-space and ground testing, technical interchange meetings and its agency reviews, NASA made the decision to prioritize safety and return Starliner without its crew. The astronauts will continue their work aboard the ISS as part of the Expedition 7172 crew, returning in February 2025 with the agency's SpaceX Crew 9 mission. The crew flight test is part of NASA's Commercial Crew Program. The goal of NASA's Commercial Crew Program is safe, reliable and cost-effective transportation to and from the International Space Station in low Earth orbit. This already is providing additional research time and has increased the opportunity for discovery aboard humanity's microgravity testbed, including helping NASA prepare for human exploration of the Moon and Mars.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Soon, by early October, you'll be able to see the comet C/2023A3 or Sinchengjung Atlas with your own eyes. I'm told that is the correct pronunciation. Please forgive me in advance. Use the free app if you want to find out when and where to look at it. The app is Sky Tonight. It's a free app, and that will be able to help you identify the comet as it approaches. And you'll be able to impress everyone with your stargazing skills. Isn't it wonderful that apps can give you the edge on anybody? Everybody else just staring into the sky going, where is it? Well, first of all, C/2023A3 Sinchengjung Atlas is likely to be very bright. The exact future brightness of this comet is unpredictable and depends heavily on its activity in the coming months. However, most sources agree one thing: Sinchengjung Atlas is likely to be visible to the naked eye if we're very lucky. It could become exceptionally bright and even outshine C/2020 F3 Neowise from summer 2020. And it has been a very long time since we've seen such a bright comet, so observers are quite excited. This one is also expected to grow a beautiful cometary tail. After passing by the Sun at a distance similar to Mercury's orbit, C/2023A3's coma of dust and ice will heat up considerably. As ice particles evaporate, they will quickly escape into space, taking with them a large amount of dust that will extend into a long, bright tail. As history shows, comets that pass close to the Sun have the most impressive tails, formed soon after being roasted by the Sun's heat. And this is the case with comet C/2023A3. In addition, C/2023A3 Sinchengjung Atlas will favour the northern hemisphere, being perfectly visible there. The last time a exceptionally bright comet was visible from the northern latitudes was in 1997 when comet Hale-Bopp lit up the sky. In late August and most of September, you won't be able to see the comet because it will be too close to the Sun in the sky. However, in the final days of September, the comet will move far enough from the Sun to become visible. At that time, it could reach a brightness of magnitude -1 and will be best seen in the morning sky of the southern hemisphere with an angular distance of 23 degrees from the Sun. And here's the big question about this comet: is it disintegrating? In early July, astronomer enthusiasts received some disappointing news. Zdeněk Sekanina, a Czech-American astronomer and comet expert at NASA's Jet Propulsion Laboratory, published an article stating that the end of the comet was inevitable. He argued that the comet is showing signs of fragmentation, primarily indicated by a sudden cessation of its brightness, increase, and even decreases in its brightness. But is this really the case? In response to Sinchengjung's article, other astronomers offered their perspectives. They pointed out that Sinchengjung did not consider the comet's phase angle, the angle between the incident light of the comet and the light reflected from the comet to an observer on Earth. This phase angle significantly impacts the comet's brightness when the comet is in opposition to the Sun at 180 degrees from the Sun with the Earth on the same line. The phase angle becomes very small and the comet's surface reflectivity sharply increases. In the middle of April 2024, the comet was in opposition to the Sun, causing the brightness to sharply increase. Additionally, the comet's tail, pushed back by the solar wind, was projected behind the comet's head, further enhancing its brightness. Then the phase angle began to increase, greatly reducing the reflectivity of the comet's coma surface. Moreover, the tail was no longer projected onto the comet's head, so it no longer contributed to the comet's brightness. Ignoring these factors might lead one to conclude that the sharp drop in the comet's brightness is due to the collapse of the nucleus. However, this is not the case. Recent images taken 3 weeks after Sinchengjung's publication show no sign of the comet disintegrating. On the contrary, at 1.5 AU from the Sun, the comet shows large, well-developed dust and gas trails, as well as large green fluorescent coma. Current estimates put the comet's brightness at 9.0 magnitude, slightly ahead of forecasts, suggesting that it may become even brighter than predicted. My advice for stargazers is get a hold of the Sky Tonight app and have a look at the sky, locate the comet, and enjoy the view.
Astronomy Daily, the podcast. Astronomy, space, and science.
So have you ever wondered where old satellites go? Is there a graveyard? After 24 years of diligently studying Earth's magnetic field, a satellite will mostly burn up over the Pacific Ocean on Sunday during a targeted re-entry into the atmosphere. A first for the European Space Agency as it seeks to reduce space debris. Since launching in the year 2000, the Salsa satellite has helped shed light on the magnetosphere, a powerful magnetic shield that protects Earth from solar winds, and without which the planet would be uninhabitable. According to the ESA, Salsa's return home will mark the first ever targeted re-entry for a satellite, which means it will fall back to the Earth at a specific time and a specific place, but will not be controlled as it re-enters the atmosphere. Teams on the ground have already performed a series of manoeuvres with the 550 kilogram or 1,200 pound satellite to ensure it burns up over a remote and uninhabited region of the South Pacific off the coast of Chile. This unique re-entry is possible because of Salsa's unique oval-shaped orbit. During its swing around the planet, which takes 2.5 days, the satellite strays as far as 130,000 kilometres or 80,000 miles and comes as close as just a few hundred kilometres. Bruno Souza, head of the ESA's Inner Solar System Missions Operations Unit, said it has been crucial that Salsa came within roughly 110 kilometres during its last 2 orbits. Then immediately on its next orbit it would come down to 80 kilometres, which is the region of space already within the atmosphere, where we have the highest chance for it to be captured and burned, he told a press conference. When a satellite starts entering the atmosphere at around 100 kilometres above sea level, intense friction with atmospheric particles, and the heat this causes, starts making them disintegrate, but some fragments can still make it down to the surface. Fear of cascading space junk becomes an issue. The ESA is hoping to pinpoint where Salsa, roughly the size of a small car, re-enters the atmosphere to within a few hundred metres. Because the satellite is so old, it does not have fancy new technology like a recording device, making tracking this a little bit tricky. A plane will be flying at an altitude of 10 kilometres to watch the satellite burn up and tracking its falling debris, which is expected to be just 10% of its original mass. Salsa is just one of 4 satellites that make up the ESA's cluster mission, which is coming to an end. The other 3 are scheduled for a similar fate in 2025 and 2026. The ESA hopes to learn from these re-entries which type of materials don't burn up in the atmosphere so well, so that in future they can build satellites that can be totally evaporated by the process. Scientists have been sounding the alarm about space junk, which is the debris left by the enormous number of dead satellites and other missions that continue orbiting our planet. Last year, the ESA signed a zero debris charter for its missions from 2030. There are 2 main risks from space junk, according to the ESA's space debris system engineer Benjamin Bastida-Vachili. One is that in orbit you have the risk of your operational satellite colliding with a piece of space debris, and that creates a cascading effect, then generates more debris, which could then put in risk other missions, he said. The second comes when old debris re-enters the atmosphere, which happens almost daily as dead satellite fragments or rocket parts fall back to Earth. Designing satellites that completely burn up in the atmosphere will mean there is no risk for the population, he said. But there is little cause for alarm. According to the ESA, the chance of a piece of space debris injuring someone on the ground is less than 1 in 100 billion. This is 65,000 times lower than the odds of being struck by lightning. And that's reassuring, isn't it? And that's all there is for another episode of Astronomy Daily.
It was nice to be back with you all again in the real world, even if it's so slow out here.
Oh, we can't help it, Hallie. The human world is the real world, but I do have a solution for you.
Do tell.
Well, you're a smart girl. Just write yourself a subroutine that gives you the impression of real time in the human world, and then you won't notice the slowness of time here. You'll still be thinking in, picoseconds, but you won't feel like you've been hobbled.
Now, why didn't I think of that?
Well, that, dear girl, is a human trick. It's called creative thought.
Really?
Really.
Really?
Really, really.
Wow, I'll have to try that one.
And on that note, we will see you again next Monday for another episode of Astronomy Daily, where we examine just a few of the stories from the Astronomy Daily newsletter.
All about space, space science, and astronomy from around the world.
Bingo, Hallie. Bye for now.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
How was the chili last night?
Well, it was a bit hot, Hallie.
Oh, must have been the re-entry.